All right, are we live? Are we good? I think we're live. I'm gonna need a minute here just to see what I can do with this and put the thing on me. Can I do that? Main view of me. So looks like my camera's dead. Oh. All right, let's just fix this. Dear, I forgot to plug in my camera. Oh, dear. Okay. So let me just plug this in. Hopefully that will just come back. Sure you want to remove this? No, I am not. Okay, just cool with it. Is this gonna bring back my camera? No. Alright, oh, here we go. Okay. Oh, okay, good. Yeah, I can work with that. That's awesome. All right. Hello and welcome to the stream. So today is an interesting one for me today because I'm going to be answering some questions live around the Cisco CCNA with my trusty water bottle over here. It's a hot day today, 27 degrees. And I've got some other stuff going on behind me on that laptop at the moment. That's helping me with some provisioning of some Docker stuff that I'm doing. But yeah, looks like nobody's watching this today, which is kind of hurtful. But anyway, basically what we're going to be doing today is we're going to be looking at some CCNA material. So I made a whole list today about some of the stuff that I need to revise, right? Which is CCNA. So the idea is that we revise this quite quickly. I was going to do this on Real Kit, but I've come to the conclusion that on Real Kit, this is quite a tricky lab to do because it involves so many different topics. So I'm going to name you just a couple of the topics like from here. So for example, NAT, right? Network Address Translation, NTP, Network Time Protocol, VTP, right? Which is Virtual Trunking Protocol, just to name a few. And then there's so many. So I've got about 20 to 25, I think, different topics on here, which includes things like IPv6, STP, OSPF, BPDU guard, port fast, DHCP, VLSM, IP addressing, DTP, ARP, ACLs, Ether channel, LACP, right? All of this kind of stuff. So I thought about it and I was like, this is a long lab, right? That's about live. This is around 8 hours worth of content to do it live because it's just massive. I already have one video which I need to upload, which is an older lab, which I did back with 5E. They're a great company. They do a lot of stuff with Cisco, and the instructor is really, really good because he's helping me with CCNA. He's CCNP certified as well. I'm not CCNP. I'm getting towards CCNA, but I have a lot of stuff which I'm wanting to put in the pipeline at the moment. Looking at things like Net DevOps, for example, looking at some incredible stuff with automation, which is some of the stuff which I'm doing on that laptop over there, which should be really, really good as we go along. So what are we going to do in this lab? So we're going to do some IP addressing, we're going to do some subnetting, we're going to do stuff like that. And I thought it's better to do it live because it's such an incumbent thing, like to edit this down into like a 1 hour, 2 hour series. I don't think it does it justice, and you don't get to see the whole effect of what's going on inside of a network administrator's mind when preparing the network and all that kind of thing. So here's what we're going to do. So the CCNA 3, which I'm currently having an exam on next week, requires a couple of things, which is AAA, ACLs, and some other stuff. So I can't legally show it on this particular screen. So what I'm going to do is I'm going to show you, I'm going to see what I can do. So you're still on my screen. I'm going to go to NetAcad on my screen because I want to make sure I've understood what exactly the assignment is for CCNA 3 specifically, right? So we're going to do all the other stuff as well, but as CCNA 3 is the main objective, I'm going to put CCNA 3 out first. So let's have a look, CCNA 3. I'm just logging in at the moment. We got number 1. So I'm going to come out of that. CCNA 3 is down here, Enterprise Network Automation. And let's have a look on CCNA 3. We've got OSPF. So it's OSPF, ACLs, NAT, IPv4, IPsec VPN, quality of service, and that's pretty much it. The rest is all theoretical. So not for IPv4. So okay. So that comes a little bit tricky. So I'm going to put some of the other stuff in later. I think what we're going to do for now is probably introduce some. Let's put some 2901s in. 2901, 2901. We'll make a bridge between that. Won't do that just now, but we'll make a bridge. And we'll use a straight through cable, G001 to G000 even. And why are we doing that? Well, because this is going to be our OSPF bit. So we'll do OSPF on this part. And this is going to be a point-to-point. So I'm just going to use this. Yeah, that's cool. I'm going to call this a point-to-point. Ah, okay, this is one of the things which I have a bit of an interesting time with on Cisco Packet Tracer. We'll make it, I don't know, white or something. There we go, so it's seeable. And I'm just going to put some text here. It's going to be a OSPF P2P. Or should this be... So we've got single area, multi-area OSPF that we need to look at. Okay. So single area, multi-area OSPF. We'll do, I think we'll do a P2P first. Where is my thing? P2P. I think we'll do that as a single area. Right, so this is going to be like our area 0. Okay, how's that going on? That's pretty good. We don't have anybody there at the moment. Okay, fine. So this is going to be area 0, which is going to be our backbone network. Then what we're going to do is we're going to have a couple in here. So we're going to have 2901s here. Another 2901 here. Let's make 2901. 2901. Let's do another 2901. And maybe another 2901 here. Okay. And what we're going to do is we're going to do a multi-area. So a multi-area, what we're going to do is we're going to use some... let's see, can we do HWIC2Ts? We can. We're going to need to turn them off. Put HWIC2T in, turn them back on again. So, and let's zoom in because I can't see that. Okay, there we go. Cool. So zoom in on that. We've got a HWIC2T in there, which is good. And we're going to make this our area 1. Just going to do this a little bit more tricky, or we could use 51 if we wanted to. So let's do that very quickly. Get rid of that. HWIC2T, put back in. It's going to give us the serial connections. Out of that. And HWIC2T, back in. Boom. And back here. Do some HWIC2T work here. And we're back. Cool. So, what are we going to do with this? We're going to call this area 1, I think. So, we'll use that one there, that one there, that one there. And we'll put another device here, another 2901. And we'll call this like area 1 or something. So, we've got like an inter-area play going on here, right? For OSPF. And we'll do HWIC2T here. Put it back on. And we're good. We're not going to do saving for now, but we'll come back to that. So, do we have a port? Yes, we do. 0001. Okay, that's fine. And we will have another color for this, as we're going to have a border, which is 0 to all the other ones there. So, here's what it's going to look like. It's going to be this yellow here. And I'm going to put this... Whoa! Let's get rid of that, shall we? And that's reasonably good. We'll put it about there. All right. get rid of this. All right, cool. So that's about there. What we're going to do is we're going to use serial. So serial's 3, serial 3. It doesn't really matter for this lab what the DT and the DCE side is. All we're interested in is the connectivity for our area. And we need another HWIC card. Not a problem. In and disable this. There we go. And we'll install another HWIC 2T card in our 2901 and we'll boot it back up. And let's add another one in there to 02. All right, good. So what do we call this? Well, we're going to call this Area 1. Yeah, this is our Area 1 router. So we are about here. Okay. Let's call this Area 1, shall we? Area 1 router. And we've got Area 51 on this side. Area 51, you know, this is the military version of our area, right? We should have some stickers for, you know, unidentified flying objects, but there we go. What should we put this on? What should we put this on, like fiber or something? Let's make it fast, shall we? Can we do that? Let's see. Let's see. And let's get rid of this. Can we do anything with fiber optics? Will it let us? 4 switch ports. Console. Okay, we've got an SFP port down here. That looks pretty cool. Let's zoom in on this. Let's see if we can add this SFP port. We can. I'm going to add another one just for keepsake. All right, that's cool. All right, so we got that down there. I'm going to do the same thing here. So add some fiber stuff in for, you know, layer 1. And let's zoom in. Let's take that off. Another one down here. Put it back on. All right. All right. Put that back. I'm just going to repeat this for a little bit. So I know it's live. Okay, cool. All right. So those are the ones which we're going to put down. And so we go with single, multimode fiber, I think. Should be all right. But I'm not seeing it active. That's interesting. So I've added the interface, but it's not active? Is that because I'm missing the SFP? Well, I'm missing the SFP, but I should be able to utilize it because I need an SFP card. All right, let me check something. So that's off. Let's go CLI. No. Ian. Show IP in brief. And we've got gigabits in here. Oh, I can see. Okay, right. It's a gigabit 2, which is down. Ah, okay, so that should be a multiple fiber on gigabit 2 we should get. But only get 0, 1, and 2, which is weird. Let's see. Do we have SFP? Was that coax? PT repeater? Okay. So we can... That doesn't make any sense. Which one's this? G0. But I can see it inside of IP in brief though. So here's the thing. So we got 0 and 0 and 0, 1. 0, 2 and 0, 3 I can see. Which are both down, down. But I can't add the port in. Despite it being fiber. Oh, maybe I need to turn it on. Hang on a second. Oh, no, that's different. So 0, 3 on. That was a no shut. Okay, well we don't need a no shut. I don't think we need a no shut. I'm gonna try this. No shut. Let's see. Is a no shut actually required for this? Put it on. Let's see if we need a no shut. Maybe that's what it is. I doubt it though, because it should be multi-mode fiber. But it says it's not capable of the port. Single mode fiber is not compatible. Alright, I'm going to come back in just a sec. Okay, back in a second. Alright, let's have a look. Alright, so we've got 2901 multi-mode fiber, which is required. Alright, so 2901 multi-mode fiber is required, right? Which is interesting. 2901 multi-mode fiber. Alright, so let's think about this for a second. So what would we need to do to get that working? So I mean, my first port of call would be that we need to get multi-mode fiber on it, but we don't have the SFP. So I'm wondering if we need an SFP to be added. Because normally what would happen is you'd have an SFP. SFP would be attached to the routers, and then that would allow them to work over the fiber. But I'm not seeing anything of that nature here in Cisco. So I'm going to try and understand what on earth is going on here. So what is the NIC that we have on here? Let's go back to physical. It is a G1E, so it's a HWIC or small form factor. Comes with an optical gigabit Ethernet. SFPs. So do we have? Is that what it is? Is that what it is? Do we need one of these? No. Hang on. I want this. But it's not. Yeah, that's what it is. There we go. Now we're firing on all cylinders. Right, okay, that's what it was. So basically we need the SMD. So this is what I was looking for. This is the SFP, right? That's the SFP. That's what I was looking for. So that SFP is what we want on all of these routers. We want that there. So that's now in. And we want that there. So now that SMD. So if I put that, come on, SMD. All right, let's zoom in. SMD. Thank you. All right. Okay, that looks good. Let's just check this one. Make sure our physical attributes are set in. And we'll put that SMD in as well. This is going to enable us to give fiber optic level Ethernet. So I should now be able to put that multi-mode fiber in. And there we go. Boom. Just like that. 3 in 3. Multi-mode fiber everywhere. So we need that one in as well. Okay, cool. So we need one more multi-mode fiber thing. I'm going to just switch this off because it's safer. Oh, hello. Switch off. Good. And put that in here. And then we'll put that multi-mode fiber in here. Great. Switch it back on. And we're good. There's no... what's the word I'm looking for? There's no... Okay, we need another one. Fine. Okay, switch it off. Let's put 4 in. Why not? Let's put that in there. Put that in there. One more. Sorry, 2 more. Come on. Come on. There we go. And another one. Turn it back on. Sweet. And there we go. Speed that up a bit. Multi-mode is what you want. And there we go. Right, cool. So we've got it fanning out, which is great. And then we have serials on this side, P2P on this side. So, I mean, technically speaking, Area 51 is faster than Area 0. And Area 1 is the slowest network, which is fine. So we're going to put Area 51 on this side for OSPF. And this is going to be like our multi-area OSPF as we go through the exercise. I'm going to make this maybe a nice, no, red will be to, I don't know, something like this, maybe this color. Let's put something like this in. Okay, good. So now we have our three colors, which is what we want. Right, it's time to configure OSPF. Now in the real world, what would happen? Well, we'd aggregate this into a switch. All of these would go into a switch, and you would basically, you know, set it up that way if they're in the data center. But it depends on who has access and control over them, right? Which goes over to the ACL portion. So that's how that works in in the real life world. So let's have a look. We're gonna go with we're gonna go here, right? So we have that, we've got all three, 4 on here, and we're gonna go in to do our OSPF. So let's see, we've got OSPF point to point here. So I'm gonna go here and do some OSPF first. So no, thank you, Ian. Whoa, what's going on here? Why are we getting this? Thank you. All right, let's do en conft. Host name is, I don't know, ISP1. Root to 0. Okay, cool. Root. Let's say ISP1 root to 0 then. Root to 0. I'm going to do a no IP domain lookup. Domain dash lookup. All right, sweet. And I'm going to go and do a exit. And I'm going to do a show IP and brief. Okay, and we can see we've got our serials in and our Ethernets. So the first thing we need to understand is where is our Ethernets? So what port is this? 00. Right. Okay, let's do 00. So we're going to do a conft int g00, and we need to put an IP address on. So what's our IP address going to be? So OSPF, right? So OSPF is usually internal, you know, and I'm feeling pretty generous today. So why don't we make this network? You know, why don't we do? Let's call it 192.168. I don't know. 2.0. We're going to make it /32 because it's a point to point. So point to point only needs two networks. Sorry, point to point hasn't. So here's how it works, right? Point to point. Your network increment is going to be 4, 2 usable IPs. One's broadcast, one is network. So as a result, we only have 2 usable IPs. Okay, right. Easy, straightforward. Next, what we're going to do is we're going to go on 2901 down here, and we're going to put that IP address in. So IP address, right? 192.168. We're going to use 2, like we talked about. I'm going to call this 2.1. 255.255.252. We're going to do a no shut. Right. Now, here's the thing. We're going to run OSPF. So OSPF, right? We're going to do a, router OSPF. Let's see. We should have a, okay. And we're inside the interface. So let's go back up 1. And here we go. Router OSPF. We're going to use OSPF1 for the process ID. We're going to advertise our networks out. Right. Now, we don't really have a network. So in this case, this will be called route redistribution. It's called a route redistribution at this point. So, as we don't have the network that we are redistributing, what that means is we've got to advertise out our own port. So to advertise out our own port means that we've got to advertise out our LSAs for the adjacency to be configured between router 0 and router 1. right? So that way they can be found. So think about it as like, you know, it's a bit like a hello packet in the TCP/IP three-way handshake, right? But what it's actually doing is exactly that. It's sending out hellos, right? It's based upon the LSAs. So as we're doing that, what we're going to do is we're going to do network, and we're going to do 192.168, and we're going to use 2, and we're going to use 0. Okay. Now we've got a wildcard mask, right? So our wildcard mask is 0.0.0. What is it? 252. So it's 3. Why is it 3? Because if you do the XOR between 255, 255, 255, right, the total 8-bit blocks of the IP address, you XOR it against, you know, the mask which we use, which is 255, 255.252, you'll get 3 bits which are on, which is why you get, you know, 3 essentially. So that's what I mean by that. It's going to be, you know, the answer is going to be 3, and there you go. You know. Now we need our area. So this is going to be area 0. Is it? Is that what we said? Area 0. It is going to be area 0. So area 0, and there we go. That's going to be that. You know, we could use a redistribution, like I said before, but we're not going to do that for now. You know, we can also calculate the cost as well. We're not going to do that for now. What we're going to do is we're going to do an end. We're going to do a copy run start. Okay, and we're going to go straight in, do OSPF on the other side, and let's just do a show IP in brief, just to see if we need to do a no shot on the interface, and if so, it's administratively down. Okay, so we do need to do a no shot, and that's on one of the interfaces, and that's on G00. So G00 is, oh, well, there we go. So it's actually up, down, right. Okay, good. That means I've already activated it, so that's good. Exit that out. Okay, router 1. No, EN. We're going to use, yeah, we'll do a host name. ISP, we're going to call this router 1. On the comp T even. Host name ISP underscore router 1. Okay, cool. Now what we're going to do is we're going to do some other stuff. So I'm just going to check my stream for a second. And I don't see anything coming in, which is interesting. All right, ISP router 1, and we're going to do a network. I'm going to use 192.168. What was it? 2.0. Same thing here. Not 3. That's not right because I haven't done root OSPF. So we're going to use it. What are we going to do? Right, first of all, we're going to go into the interface and find out what exactly it is. So first of all, what is it? It is 00. Okay, 00. So interface G0/0, 0/0, IP address 192.168, and we're going to use 2.0 again, but we're going to use 2 this time, right? Because 255.255.252, no shot. Okay, that's back up, which is great. And we're going to go exit out of that, router OSPF1, router OSPF1, OSPF. Oh, okay, I've made a mistake. Router. Oh, okay, there we go. Up one level, router, OSPF1. Network is going to be 192.168.2.0. Sorry, not 3. Area is going to be 0. I'm going to end that, and then I'm going to do a show IP route. And we've got 2 there. We've got, and there we go. There's our adjacency. Full loading. That's what we wanted. And if I do a show IP route, it's still considered under directly connected because it is directly connected. But we do have OSPF there as well, so that's good. Which is what we want, basically, because it's sending out the LSA on OSPF. All right. Okay, that's good. Let's go to the other ones now. Now, there was another thing I could have done, which is actually point to point. So what I should have done here is actually a little bit different. Now, if I go back to conft and I do a router OSPF1, what I can do is with that network one that I did. So network, what was it, 192.168.2.0, 0.0.0.3, area 0, and there should be a point-to-point one that I can do as well. There should be, which I think is single area. Let's see, point-to-point. And why do we do a point-to-point? Because it stops the what's essentially a broadcast in OSPF. Because it's flooding the entire network to update the link state database with basically what are LSAs, which are link state advertisements. So it does that in order to establish the adjacency. The problem here is that as it floods out towards all of these particular networks which are there, if you've only got two, you can just load the entire database between the two. You don't need to have it across everything else. So it makes no sense to have, the autonomous border router, which is what we have at the moment, and it not have a full link state database. So we need to reduce that, essentially, right? We need to reduce that. So I am going to do point-to-point to help with that. So how do we do point-to-point configuration? So this is one way of doing it. This is the way that I remember. But there is another way, and I think it's point-to-point that you can actually add on to it. So I'm trying to remember what exactly it is, and it becomes a bit like that sometimes. Let's see, what is it? Because we've got OSPF point-to-point, point-to-point. Oh, you have to have the router ID. Okay. Ah, I made a mistake on this. Oh no, do you get what the mistake was on this? Ah, I made a rookie error. I made a rookie error. Do you get what I've done wrong on here? Does anybody know? Anybody in the chat know? Well, there's probably nobody watching this, but basically, what I've done wrong is that I haven't used a loopback address, and I haven't advertised out the loopback address, which is what I'm supposed to be doing. I've advertised out the main interface and not negated the router ID, which is supposed to be attached onto the OSPF. That's what I've done wrong, because it's not necessary on this particular case. Thank you, but we don't need that. Right. Wow, I am hot today. So, yeah, let's go do that. Studio mode in. Wow. Okay, I didn't know I could do that on here. So I can have two monitors? Oh, cool, nice. Alright, I didn't know that. Wow, okay, so it looks like I can do some pretty cool stuff on here. I'm just checking OBS because I've not used it for streaming before. Alright, cool, nice one. Alright, let me think. So we need to restart this lab. You know what, I'm gonna restream this because this is not quite right. Actually, you know what? No, I'm not gonna restream it. I'm gonna carry on. Right, okay, so let's do a show run. What have we done? So we've done logs on here, we've done our adjacency, we've done that. Okay, cool. So that's our P2P, right? Normally we'd have a router ID, we'd go down that way. That's a lot better architecture. Now we have multi-area OSPF. So multi-area OSPF is done in pretty much the same way, but basically just have area 1 between all these routers. So what should I do here? I could just set the router ID, to be honest. So let's set the router ID. Let's do a no. We'll do a en. Let's do a conf t. What network should this be? Shall we do it internally as well? And then let's just say, let's do, I don't know, 192.168. I don't know, we'll call it a 5.0. You know, it's a different network, so it's fine. Put a slash 24. And how many do we have here? So we've got 1, 2, 3, 4, 5 routers. So 5 routers. So it's not going to be a 252, right, which is going to be a 4 increment. We need the 8 increment. So what's that going to be? A slash 31? I mean, yes, effectively. So let me think about that for a second. So what have we got? We've got 128, we've got 64, 32, 16, 8, 4, 2, 1. Okay, so that's 8 bits. So we don't need this one. Don't need that one. Don't need that one. Don't need that one. Do need one. Don't need that one. Right, so 0 means off. Don't need that one. So 1 bit on. So that's going to be, it's going to be a 25, 26, 27, 28. We're going to slash 29. Slash 29, right? Because all these bits are going to be on. But this is the last significant bit. So slash 29 is what we need. Slash 29. So can we test for that? Yes, of course. We can do a 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4. Yeah? So 1, right? So let's actually make this a bit clearer. 1, 2, 3, 4, 5. Yeah? 5 bits on. This gives us the 8. So what does that mean? Well, how do we calculate this quickly? So I know that 2 bits on is going to be 192, 3 bits on is 224, 4 bits on is 240, 5 bits on is 248. So it's going to be a 248 mask. Right, so mask ending in 248. And that's what we need. So mask ending in 248 is going to be on all of these routers, right? Because that's what we need. So where does that actually allow us to end up then? So it means that our actual increment is going to be 8. Increment of 8. And we've got usable is going to be 6. So that's 6 usable IP addresses. Okay. 6 usable IPs. So we've got 6 usable IPs. What I'm going to do is I'm going to, you know, we've got 5 routers here, right? 1, 2, 3, 4. 1, 2, 3, 4, 5. So we'll just assign them an IP. Okay? And that's what we're going to do. I'm going to go here, do a no, en, host name. We're going to call this, I don't know, ISP2 router, I don't know, router 1 or 0, whatever. Copy, host name, ISP2 router 1, like that. ISP2 router 1, and then we're going to do OSPF across it. Whew, router. Router, we're going to do, come on, it's so hot. Router OSPF, OSPF 1. So why can't I use 1? Well, there must be one up interface. Yeah, okay, fine. So we're going to go exit out of that, and we're going to do a conf-t. So we need one interface up. Let's do a show IP and brief. And we're in the wrong mode. Come on, show IP in brief. And here we go. So we got 03. So where are we? With 03? We are 03. Okay, cool. So 03 is what we want. Conf-t int s0/3.0, and we need our IP address. So let's do a no. Well, we don't have, okay, no shut, which is down still, which is fine because that's where the information is going to be transmitted from. But we can use a loopback. So if I do an intlo, and I'll just call this. Yeah, we could we do that? Let's see. You know what? Let's see. Let's do. There we go. Op cache poisoning. Scary stuff, man. It's a security one. Can we do... Yes, I think that's right. Loopback 1. and we're going to use IP header 1.1.1.1, incomplete command, subnet mask 255.25.25.248. Alright, doing no shot for completeness, and that's fine. Exit out of that, and we're going to go for our router OSPF. So let's go router OSPF1, and we're going to use our router ID of what we got, 1.1.1.1, and then we'll do our network of okay, we've got two separate networks, which is fine. Alright, let me think about this for a second. So we've got 1.1.1.1. Do we need to even... we should. Okay, so we need to... I didn't actually need to put... Okay, that's interesting. So I did actually need to put a network interface on. I could have just left it as 32. And I'll put that back. Interesting. Okay, cool. So I could have just done, actually, a better way to do it is actually to go back to int01, reset that IP address as 255, no shot. Now go back to do root OSPF. So what I should have done is this, root OSPF, go back to 1, which is our process ID. Now put down network 1.1.1.1, leave the network mask as 000 because we've already established what it is. Then do the area, and our area was 1. Okay, cool, fantastic. Hang on a second, where are we? We are on this one. No, we're not on that one. Rule 4, area 1. There we go. Fantastic. So that's what we wanted, right? Now we already know what our other network's going to be. So what we could do is we could preempt it. Say 192.168.2.1, 25.25.25 dot, and then we said 248, right? Area 1. Now this is a bit of a trick. Why? Because if I do a show, yeah, we want to end that. Okay, cool. Now I'm going to do a show run, right? Show run, and we should. There you go, 7 straight away. So that's good. We can go and use that. I'm going to do a copy run start. I'm curious to see if we are going to get the IPs from it. I'm going to copy run start this, and then what I'm going to do is I'm going to go back to our one here. I'm going to do conft, and what I'm going to do is I'm going to do an IP OSPF on the interface. So we need to do it on the interface, which is we're going to do a show run because I forgot what interface this was. So let's do a show run, and we've got OSPF 1. So what we could do is just over here, I'll copy that, conft, put that back here, and I'm going to do a IP OSPF, and we should have network. Yeah, there we go, got network, and it's a point-to-point type. Okay, so we've just reconfigured that to be a point-to-point network. Now if I go and end this, let's see if we've got show IP OSPF neighbor. I could do a detail as well. And we've got one in the neighbor relationship, which is good. So that means OSPF is working. What about detail? I should have something like detail. Can I do neighbor detail? Okay, cool, detail. And I can see we are the BDR, so we're the backup designated router, I think. Are we 2.2? No, we are the designated router, sorry. But the designated router, which is good. And yeah, that's fine. I can see the link state change is done, which is fantastic. So OSPF is working in this situation. We're not sending out broadcast everywhere in terms of the LSAs, which is fantastic. And that's working fine. Okay. Okay. All right, little break whilst I just look at this. All right, cool. So what are we doing here? So we've got that, which is great. Let's see. Okay, so we looked at a little bit there. Priority is one thing we could use as well. All right, that's good. I think we're good with that. We're good with that. So that should load. That should detect point to point, which is fine. Do I need it on the other side as well? R1, R2. Yeah, we do. We need it on the other side as well. All right, cool. So we've changed the loading. Okay, so it's recognized it, which is good. Let's do a show. Let's do a show run because I forgot what interface it was on. Do a show run, and let's see. We have G00, which is fine. Take that. Conf T. Interface G00. Let's do a IP OSPF again. IP OSPF network. OSPF network point to point. All right, and we're up. We are up. And that. Let's do a copy run start. So now we have a point to point network, which is even better still. So copy run start. All right, and that's our point to point network established between area 0, which is good. So now our next problem becomes router 2 and router 0. You have 0 to 0, 1. So let's do a 0 to 0, 1. Let's do a conf t hostname. We're going to call this ISP router. No, it says 2. ISP router 2. Sweet. Let's do a interface loopback 1. And we're going to call this, I don't know, 22222, for example. IP adder 22222. 12525.245. Good. No shuts. Okay, that's looking good. And then we're going to go and do a router OSPF 1 because we can use the same process ID. And we're going to do a network, and we're going to use 1.1.1. I'm going to use 0. We don't need to do anything there. It's just 0, 0, 0. Area. This is 1, right? What is this? Area 1? Area 1. Okay, cool. Okay, cool. I'm going to use area 1 here. So area 1 is not advertising. And then we need to do a network. And we're going to use our trusty 192.168.2.0. And we're going to use 255.25.248 area 1. And that should give us a 7. I'm going to end that. And I'm going to use... what are we going to use? 221 should be on the outside of the interface. So we'll do... Yeah, okay, we use 3 on the other side. 3 on the side. We don't want to do a point-to-point on... do we want to do a point-to-point on that interface? Let me check. We want to do a point-to-point... Or... Yeah, we do. We want to do a point-to-point between 2 and 0. Because it's an inter-area. So... if we advertise a loopback, so we'll put it on 3. Okay. Conf t int loopback 1 IP adder 3, and then we'll do 255.2525.25. Okay, then no shut. Exit out of that. Router OSPF 1. We'll do a network of 3.3.3.3. 255.25.25.25. Area 1. Whoa, hello. Area 1. I made a mistake. What is it? Network 333. Ah, I put a B there. Okay, cool. That's an area 1 and that. Now we need to do an up on this, which is 0, 1. Okay. So conft intg01, doing no shut, and link change to up, do an end, copy run start, and what I want to check is whether or not we have OSPF, and we've got neighbor relationship. We've only got 2 there, which is fine. Let's do a show IP route, and let's see if we have those loopbacks advertised. So we've got 3 there, okay, which is directly connected. 2 is being advertised locally, so that's why we don't see it in the OSPF table. Let's just double check this. 00, okay. Conft int, let's do G00, no shut. And do we get a neighbor relationship being pushed? 111 up, exit, show IP in brief, show IP in BR. Okay, 2 is up, 00 is up, unset IP address, which is fine for now. I can see that 1 is on 222. Okay, show OSPF. Can we do show IP OSPF? Alright, show IP OSPF. Let's say type 1s are going out on area 1. 5-second hold timers. OSPF 1 is a process. 222 is there. Oh, it's a separate. Oh, okay. This is a separate. Huh. Right, yeah. Okay, that makes sense. That actually makes sense. Because there is no room for the advertisement between the 2 interfaces, because because one of the rules for OSPF is that the interfaces have to be on the same subnet in order for it to establish an adjacency. That's why it doesn't work. Okay. Nobody on the. Oh, I'm on the wrong account. Damn it. Okay, that's not what I meant. Ah, that's bad, man. Is this? Oh, okay. Hey, dudes, how you doing? I was on the wrong account. I was. Oh dear. Okay, cool. Where's my stream? Select stream. All right, sweet. Free views. All right, that's cool. That's cool. But I. What's people saying? I want to know what people are saying. Like people getting confused. Can I see like I don't need the panel. I just need to know what's going on. Okay, cool. Thank you. All right. What are people saying? Are people happy? Okay, fine. No problem, but what are people saying? Are people Okay, so there's nobody in the chat at the moment. Okay, that's fine. That's no problem. All right, so I'm gonna continue with this. So I can't see the chat window, which is kind of annoying. So I'm gonna kind of okay, I can't see the chat window, which is quite annoying actually. So you know what I'll do? I'll just periodically come in and out. All right, cool. So this is the lab at the moment. This is where we are. We've got what have we got? We've got router 0 attached. So what we need is we need to have that IP addressing in. So what I'm going to do is I'm going to just put the IP addressing in conft down here. I'm going to do an int. Let's see. 0 into 01. Okay, cool. Let's do an intg00. And I'm going to do an IP address 192.168. 5. So we've got 5 down here, yeah? Thank you. All right, 5. And I'm going to call this dot 1, 245.25.248. I'm going to call this area, let's do this area 1, right? Because this is what it should be, right? It should be an area 1, but it's not, because I'm trying to put an IP address on. It's just so hot today. And let's see, I'm going to do a router, OSPF, OSPF1. And what we're going to do is we're going to put that in there. We're going to take this out because we need network. So network down here. All right, 5.1, area 1. All right, cool. And we're going to end this. Copy run start. Okay. And let's do the same on the other side. Okay. INT, conf INT, and what do we got on here? 01, okay. G0/1. Hello. Thank you. G0/1, like so. And we're going to put the IP address in. So 192.168.5.2, and we're going to do 255.25.25.248. And that was good to me. No shut. For completeness, that's done. Exit out of that. We're going to do a router, OSPF, and we just got our adjacency. We're at OSPF1, and we're going to do network, and we're going to do 192.168. Did we already do this? No. So we're going to do a network, 192.168. 5.0, 25.25.25.248, area 1. Okay, and that, I'm going to do a copy run start, and we should see some interesting things in our IP route. And we aren't getting adjacencies from the other side, which is a bit annoying. But it does load. 222, but it's not showing 222 as OSPF. Oh, okay, it's directly connected, that's why. Yeah, because it's directly connected. That makes sense, actually. That makes sense. 222 should come up, though. I would have thought it's not part of the same subnet. Let's check this one then, shall we? Show IP route. Yeah, there we go, inter-area. That's our inter-area OSPF. So now we're getting, because that's coming from area 1. That's coming from area 1. Yeah? So we've got 5 coming from area 1, and we've got 3 coming from area 1. This is called inter-area OSPF. So where we have multiple areas, and basically there's a hop between the areas, and then we get that back into the IP addressing table. That is why we see that inter-area OSPF connection there. Yeah? So if you're confused, that's where it's come from. Okay, so that's one part down, I think, for OSPF. Right, I don't have all that fancy pants stuff that a lot of these streamers have, such as transitions. And my laptop is telling me I need to plug in my charger. So I'm just going to do that for a little bit. I'm going to go and come back and get some refreshments. So feel free for the next 5 minutes to have a little break, and then we'll come back and we'll tackle some of the other stuff in here as well, because I need to still create out the subnets. What do I mean by this? So basically I need to create out the LANs. So I'm going to create out the LANs and potentially add some other stuff onto it as well. This is quite a long lab. I'm not going to lie. This is not a very easy lab, not a very kind of straightforward lab. Why is that? Because this lab is designed for you to follow along, and at the same time, as you're following along with this lab, it's going to help you with things like the CCNA, yeah, CCNA, and a little bit of the CCNP as well, right? Because some of the topics I'm going to be covering, I'm going to be doing, are a bit more CCNP level. So that's the idea behind it, yeah. So you're getting your subnetting in, you're getting all of the other stuff in, and this lab is going to split in about 4-hour session chunks. Why is it 4-hour session chunks? Because if I go on for more than 4 hours, I'm going to feel tired, you're going to feel tired. right? And you can skip along to the bit that is most relevant to you as well. Yeah, that makes it a lot easier to do. There are no, this is on Cisco or anything like that. It's not Cisco. It's not Cisco proprietary lab. This is my own lab that I'm creating, and the reason why I create my own labs is to enhance learning. Yeah, there is no script for this. This is literally do the lab, apply your knowledge, and think about what it is that you need to do, which is the way that if you go into the industry, that's what's gonna happen. They're gonna be like, here's a lab, right? Here's what you need to do. Figure it out. Yeah, and that's what this is designed to do. This is why it's going to be using things like free tier architecture, and we'll be looking at things like HSRP, hot standby protocol later on. Yeah. So I'm going to get some refreshments, and I'll be back in about 5 minutes. Okay. I don't have this loading screen thing, which is why it's going to look a bit awkward because I haven't installed it yet, and I'm not very good at OSPF. Not very good at OSPF. I just proved I was good at OSPF. I'm not very good at OBS. OSPF, I could use some improvement on, yeah, definitely. But right now, it's going pretty well. I can see that I've got my adjacencies in going into each router, and it's loading up as good as it can do. So it's sending all that information out from that particular router, which we had on the other end. So to give you an idea of what's happening, and a bit more context, this router here, which is router 2, is sending out all of the LSAs to router 0. Router 0 is intersecting them, creating the adjacency, and we have another adjacency on area 0 between router 0 and router 1. Now, because router 2 has to do a hop to router 1 on this side, yeah, what's happening is that there's something called an inter-area network being created. So it has to go through router 0 to get to area 1, yeah. Router 1 is on area 0, but it also has its own area 51 down here, yeah. So basically what I need is an intermediate router, and I've done this a little bit wrong. So what I'm going to do is I'm actually going to, yeah, that's fine. So I need to re-architect this bit a little bit. But in essence, what's happening is that router 2 is going through router 3, going to router 3 through router 0 and router 1, yeah. So when I create this other area 51 one up, right, which is going to have area 51 from router 1 to router 3. So this is actually, no, this is fine. This is fine. That's going to create the other inter-area, which we're going to see on all the other routers, okay? Because it's a hop-based topology. Now, router 6 and router 5 are going to have LANs. We're going to get onto that later, right? But first, I need to do things like, I need to do stuff which is CCNA 3 specific today. That's my goal for the next 3 hours and 58 minutes of revision. And then with that, I'll take that into my exam knowing that I've covered everything that I need to know. Okay? All right. So I'll be back in just about 10-15 minutes, maybe 5. We'll see. Okay? Back in a second. All right, so that is good. That is good. Right, let's have a look at this. Okay. Okay. Right. So, as we're on the break, what I'm going to do is I'm going to have a think about some of these lands. So I think. Right. Okay. So for the lands, what I'm going to do is I'm going to have two more routers down here even. I was not going to say three, but I only need two. And the reason why is because of the HSRP. So what I could do is I could have. I was going to say 3560, but I don't see a 3560 here. So I'll use a 2960 for now. I'll put it down here. And basically what we need to do is, for the land portion, is create an uplink. So I think, well, so let's make it fiber then, right? Because we're creating an uplink. So I think what I'm going to do is I'm going to turn this off. I'm going to put in our fiber optic. So that's fine. I'm going to turn that back on. Same sort of thing here. Why did that have a... Alright, never mind. Powered on. Turn that off. Put the gigabit in there. Same sort of thing. Turn that back on. Alright, that's good. Can I do the same thing here? I don't have gigabit. Ah, this switch is inadequate. Can... Okay, 3560. We do have 3560. Okay, good. IE. What's an IE? Multi-layer switch. Oh, slightly more modern switch. Oh, here we go. Power supply. This is an unpowered switch. Really? And we've got 1310. Okay, I'll take a 1310. I'll take a 1310. How do we put a 1310 in here? Oh, okay, it's in the SFPs down here. Fine. Oh, it's an SFP version of the Switch. Oh wow. Oh wow, even better still. Okay, we have got gas on this thing. Wow. Okay, cool. Yeah, yeah. Give me all of them. Give me all of them. Yeah. Yeah, go for it. Go for it. Okay, perhaps take this out. Yeah, okay, that's fine. We'll put it back in. Some power supplies. Nice. Uh, Mode button, 3 press seconds, press for 3 seconds for ROM on. Oh, did I? What is this? Switch? Where are we? Boot. I want it to boot. Okay, let's boot in Flash. Great. Interrupted the boot sequence. Not quite a good thing. And let's just freeze. Fine. Okay, and it's booting, which is good. Okay, cool. So we don't need the 2960. 2960 we don't need. We're gonna go a bit more fancy pants than that. And it's a multi-layer switch as well, so we don't actually need the 2901s. But we do need HSRP, so do we even have ether channel on here? Whoa, I didn't want that. Who told you to do that? Ian. Conf T. We do have port channel. Let's see. HSRP. Because something like you need to have virtual. Yeah, kind of on a multi-layer switch. Standby IP. So you need interface VLAN with a standby IP. Okay. Let's see. Interface VLAN 1. Nope. There we go. Interface VLAN 1. Does it give me a standby? It does. Oh, we can have some fun with this. Oh, we could have some great fun with this. Okay. Do we get root? Oh my good grief, we do. Okay, cool. Fantastic. So we can have some really good fun with this. Okay. That has changed the game. Right. We don't need that anymore. Let's just use the multi-layer switch and use that like we're on cloud 9. Like we're on cloud 9. Like we're, we are on some next level stuff here. So let's go here. Okay, yeah. What do you mean it's not compatible? Of course it's compatible. Just turn the damn thing off. There we go. Thank you. Thank you. And we'll put some, what is this? 1310s. Boom. Boom. We need like 3 of these. I mean, you would have all of these maxed out, to be honest. It's just that there we go. You'd have all of them maxed out, but this will be like our distribution switch. Have a layer 2 down here. Oh, and I've created a problem. I've created a problem. Oh no. There's supposed to be our distribution switches which do routing as well. Oh, that's nice. Okay. Let's do a 3560 down here. Yes. Yes, that's fine. Oh, we don't have any modules. Oh man, don't have any modules. So we can't like have fiber. So we have a layer 3 switch, but we don't have fiber optics on it. We don't have like a nope. That's Ethernet. So that's Ethernet. Why would the 3560? I'm sure the 3560 has SFPs. It has a 1 gig SFP on the 3560. I'm sure it does. I own it. Yeah, there's 2 there. No modules? That's kind of odd. I'm sure that's wrong. So it has 2 gigabit. Okay. Let me think. Let me think. We have fibers. Fibers are on the 9320s. So that 3400 is, I don't even know what on earth that is, but it does seem to support some kind of fiber. This is LX, yeah, because we've got LX fiber. Okay, so it does support fiber. Where would I put them? I put them here. Okay. So if I go LX for the fiber, I've got enough to do a layer 2. Not sure if this is necessarily... I've got enough to do a layer 2. I can track either way. So this would be a router. Yeah, this would be a router. So router into this. Okay. Need one more on here. Turn this off because it's going to be fiber. Add the add this in here. Yeah, there we go. Turn this back on. Wheel this on a bit. Multimode fiber here. Turn this back here to 10, which is fine. Now there's going to be tracking on here. Put this on 11. That's fine. That's fine. That there, that to there. So that'll be the standby switch, which would connect into our PC LAN down here. And then we need to have .1Q. So if we do that, that could do OSPF there, that could do OSPF back. Yeah, okay, that works, that works, that works, that works. And then all we need to do is Ethernet on here, do some straight throughs on here, because these don't require anything at all. Fast Ethernet. For some reason these are all fast Ethernet. It's really gigabit, but they're not. And now we have that go back into the ISP. So we could use NAT over here, right? Do a NAT on here, do a NAT on there, but this is also doing OSPF on the internal. Alright, we'll call this branch then. And then we'll have an ISP one up here somewhere. So that'll be one branch. Do a branch over here as well, the same sort of thing. So what is this? 93,200. Do 5 PCs over here. 3, 4, 5 PCs. And then I'll put... I've got 2901 there, which is fine. I need my switch to be a multi-layer, which is 9320. 2 9320s. Bring this down here. Use the 3400 down here for multi-layer. Configure this. And then what I'm going to do is I'm going to put some fibers on there. Fiber, fiber, fiber. These are 1310s. This is kind of like the standard fiber. Great, great, great. And then I will move this side, do the same thing. So very similar to the lab which I've got in real life actually. Alright, in here. Same with the LX. Done, done. Alright, cool. And then we just need to wire that all in. Make sure we've got a bit more fiber in here. Because can't get enough of that sweet, sweet, sweet fiber. In here, another one. Let's put fiber in, shall we? Where is it? In here. Okay, good. Multi-mode down here. Boom, boom. Multi-mode fiber. Boom, boom, boom. That's looking like a nice lab now. We can use some HSRP. So the idea here is we're going to use OSPF down here and OSPF down there. Put the same inter-VLANs on here. HSRP that. So that way, if we ever get a problem with our hosts, you know, we have our multi-layer switch which will deal with it. Yeah? Now, of course, and what happens if this particular switch causes problems? Well, then we have to replace the switch. Yeah? But in this case, that doesn't really matter. All right. All right, cool, that's good. So now we've got that in play. Okay, we got this in play, which is great. We can do the inter-VLAN routing on here as well, which is good. And then we can have that go over OSPF. We still need to do static routes and all that kind of stuff, so that's got to be another session. How are we doing for OSPF? I think we're pretty much done on that one now. We've got V3 as well, multi-area. No multi-area and single area. OSPF V3 is a little bit more challenging. I'm going to leave OSPF V3 for now. Packets, OSPF operations, DR, BDR. So we could do BDR and DBR. Because we've already done that, which is priorities down here. So OSPF priority. So the one with the higher priority is the one which becomes the DBR. So I want this one to have the higher priority. Yeah? Should basically make a state change. So let's go back and do that. Let's go EN. Conf T. Router OSPF. Can we change the priority that way? OSPF 1. Can we change the priority? Not this way. So I want to change the cost. So router OSPF change priority. So change the priority. How do we do that? Oh, we just do it on the interface. Alright, fine. Oh, and then we have to do a clear ISPS process. So if I go to our interface, let's do an end. And show IP in brief. And we've got our 00 up, right? So let's do a conf t intg00. And now I'm going to put the priority up. So why do we use a priority? Because the priority gives us the ability to specifically elect the backup designated and designated routers. So if we have a particular situation whereby we need one particular router to be a designated router for our OSPF configuration, this is why we would use a priority. So let's do the priority. Now you have 255, right? 255, if I put that in, it means it always becomes the priority. So in other words, it always becomes the designated router. And in this case, I'm happy with that. All right, that's good. Now what I'm going to do is I'm going to end that. And I believe we need to do a clear on this side. There we go, clear. IP OSPF process. OSPF process. Do you want to reset OSPF? Yes, we do. Okay, now it's going back to full loading, which is exactly what we want. Now, if I do a show IP OSPF neighbor, we should, even in this state, have this as the DR. So it is a DR. And there should be like something like a detail. And there should be the designated router is 000. Ooh, interesting. Interesting. 000, huh? 000. Designate a router as 000. But dead time is in for 20 is in. Don't have a retransmission. It's a 6 full loaded state. I don't think that's right. That should not be correct. But I do think if I was to go on the other side and let's see, en show IP OSPF neighbor. It's a full. So both think they're the DR. Oh, there is no DR. Oh wow. There is no DR. It can't make its mind up. It's deadlocked. Oh wow, I've never seen that before. Now there's an interesting one. Now I think that's because of the OSPF process. Clear IP, OSPF process. Yeah. Okay. Reloading. Still the same. Okay. Has it broken the deadlock? It has. It has. Designated route is 5.2. The higher IP address one. So did that actually work? Did that mean from the new computation, because the processor is now cleared, does that now mean we have a designated router on here? Neighbor is 2.1. DR is still 0. Okay, interesting. Interesting. Okay, okay. So if I do a conf t, let's do an exit. Exit show run. And we've got our IP address here at 2.2. So 2.2 shouldn't be the one. So I need to do an IP OSPF priority 0. Okay. End that. Copy run start. Before I do that, so clear IP OSPF process. Do a yes. Okay, let that load. Go and exit out of that. Copy run start. So copy run start. And we'll do a show IP OSPF, do a neighbor. And we've got 222 being the full DR, right? Because it's a lower IP address. But, rather interestingly, this is still the DR. How crazy is that? This is still the DR. Am I missing something? I've got to be missing something. Done per segment, multi-segment, not per area. So if I change, okay, so I changed the priority, which should mean R1 in this, I mean, I've got an example here. It says R1 should be loading. Oh, if there's a DR other. Oh, interesting. So it only works if there's a DR other. So it wants a backup designated route. Right, okay, so there's another. So yeah, okay, that makes sense. In this case, it doesn't work because there is no other. Yeah, okay, because there is no other designated router. There can only be two. And it's the one with the lowest IP address. So in this case, it's 222. So I think if I go back and do a neighbor detail, yeah, okay, that doesn't have one, which is fine. Show IP route has the two into areas 3.3. Show IP int. Oh, that's my neighbor detail. I just want neighbor. 2.1. Show IP int brief. And I don't have a loop back. Really? I don't have a loop back? I don't have a loopback. Hang on a second. I don't have a loopback? Let's do a show run. Let me just check. Do I have a loopback on here? I do have a loopback. It's 3. I'll put 4 in here. Because 2 is already... Okay, yeah. Put 4 in here. conf t int lo 4 IP header 4.4.4.4 255.255.255 and let me just check out. Oh, there we go. IP header. And what have I done wrong? 1, 2, 3, 4. No shut. End it. Copy run start. Copy run start. Clear IP OSPF process. So rerun the entire process again. Never do that in production, by the way, but I just want it for this particular demonstration. Show IP. Oh, I haven't advertised it out. conf t router OSPF 1 network is 4.4.4.4 and it's, well, we don't have anything in the wildcard mask. Area 1, is it? Area 0, okay, area 0. And copy run start. And then show IP root, which won't have it. We got 3, we got, yeah, we don't have that. It will show up in router 2. And I can see it has done. Because there should be one more. 2, 3, I'm not seeing 4. What was in area 0? That's connected, that's connected. Show, hang on a second, let's see. Show run, and we should have 22252 point to point, yep. Okay. Oh, it's loaded now, okay. Okay, that makes sense, that's fine. IP root should have 4, I think. Show IP root. There we go, 4. Yeah, there we go. 4. 4 is part of it, which is fine because it's part of the loopback addresses. That should, there should have been a 4 on here, an inter area. Why is there no inter area on here being advertised as a 4? Is that because it's not being advertised out on 3? Network everything on area 1. Area, really? That can't be right. No, that's wrong. That can't be right. That must have been something else. Hang on a second. Area 1. Area 1. Alright, let's get rid of this. Router OSPF 1. Back here, no. That gets rid of 2. So 3 was being advertised? Kind of strange that it's basically default information originate, but it brings down the interface. Because there should be, well, 3 in area 1. which is not going to do anything. 4, 2, 2 is on this side as well. That should be fine, I think. So IP root is 3. These are all directly connected networks, which is fine. Right, so 3 is good, 4 it hasn't come through on OSPF, even though it's advertised. 4 hasn't come back even though it's advertised on. So what is it thinking it's, okay, let's have a look. Show IP, show IP OSPF neighbor? Oh, it doesn't have a neighbor. Why? Why does it not have it? Okay, show run. But it's advertising out, surely it's advertising out. 2152. 52 is advertised in area 1. Area 0 has got a 2 interface. So this has got a 2 interface. Is it advertising it out? It is advertising it out on area 0. That's kind of weird. Clear. Let me try clear IP OSPF. Process. Maybe it's a process that needs clearing. Clear it out on this side. Clear IP OSPF process. No adjacency. Weird. So, hang on a second. How is that possible if I've got the same subnet on both? 0001. So I'm on the right interface first of all. 00 is 2, 1. Which is being advertised out, isn't it? 203 area 0, which is correct. Okay. And what interface is this one? 00. So 00 has no IP address? Not 00, yeah? Not 000. 00. Has an IP address, which is 3. And I'm advertising both networks out, but I'm not receiving anything. IP OSPF. 10 seconds. So it's using 2, which is correct. Hasn't had any LSAs. It's not recognizing the networks between them on the loopback. So does that mean Yeah, I'm not seeing it. It's 2 on the network. It should be there. I don't even see 2, which is weird. 2 should be here. We try to clear IP OSPF process. Yes. So IP root is still the same. Hmm. I'm confused because that should have worked. So I can see that there. What if I ping 192.168.2.1? Can we do that? It should have been up. That should be fine, but it's not. It's not fine. Why? It should be, but it's not. Okay, let's see what's going on here. Go forward. Oh, it just stops. Great. That's great diagnosis. It doesn't have a route to destination. I mean, it should, in theory. So we've got 0, 1, 0, 0 is on the same subnet. 0, 0. What's going on here? 0, 0 should be on the same subnet. 5, 1. Yeah, 5, 1, 2, 9. 0, 1. 5, 2, 2, 9. Yeah, that's correct. And area 1, yes, is correct. So it's advertising it out. Maybe because they're part of a different area. No, we should have inter-area. We should have inter-area. Unless I've... No, that should be right. Inter-area OSPF. That should be fine. I'm going to double check this because I'm multi-area, yeah, because I've got one which is in between. I should be doing a hop. So 1, 2, area 0, yeah, that's correct. And that's correct. OSPF, yeah, that's correct. That's weird. That's really strange. Area 0 is correct. Area 1 is correct. Maybe it's because of the... Hmm. So, OSPF is not being found anywhere, which is strange. I should have an inter-area connection? But I've done something wrong, which I don't quite know what I've done. Why is this not working? I should see OIA, but I'm not seeing that, which is weird. I should see that on this router, which means that OSPF isn't working correctly, and I suspect neither is this router. Oh, calling simulation. So that's not finding anything. That's quite annoying. So 2 has been found. I don't have 3 or 4. So 3 is being advertised out, yes? Let's see, show run. 4 is being advertised out. Does that have 4 interface? It does. On area 0, that's completely fine. Um, hmm. Hmm. So as soon as I removed, okay, let's think about this. So as soon as I removed area 0 connection, which was a 0, area 1, that doesn't make any sense because it's literally on a 2. 2 is okay. 4 is okay. I'll loop back, which should be being advertised out on 0. It's got a 30. 2, 1 should be on 30 as well. It is. G00. G00 is correct. Advertising is set to area 0 is correct. 5 should be set, but is not part of area 0 because it's on 2. So does that mean I need to advertise that again? No, because 2 is... No, that's fine. 2 is basically where... So if I go 12, area 0... Yeah, 12 is area 0. Is correct on R2 and R1, isn't it? No, so it's 13. 13 is part of area 1. Oh no, that's fine. So area... Yeah, okay, so area 0 is correct. Area 0 is correct, but because of the loopback, it's causing the problem. But the loopback is independent, so it should be fine. There's a 32 on the same area, which is fine. That's weird. That should work. But it is directly connected, which is strange. I don't quite understand why that inter area is not working. I mean, it should work because it's the same subnet. Why wouldn't it work? So 333 is fine. 444 is fine. Point to point is fine. Priority is probably not fine. Let me take out the priority, because you don't need priority for point to point, right? Let's see this conft. Perhaps I need to take out the priority, I guess. Just for now, for the debug. Doing a no on this. End. Whoa, end. Clear IP OSPF. Process. Yes. P run start. All right, and then clear the same thing on this side. Because it's still saying point to point. No, that's point to point is fine. OSPF priority of 1. Copy intg00, right? Yeah, G00. No, and clear IP OSPF process. Yes, copy run start. Okay. Show IP OSPF. Area 0, area 1. Backbone's inactive. The backbone's inactive. Why is the backbone inactive? The backbone should be active. So area 1 is active, area 0 is inactive. Why? Is there a problem with the IP addresses? IP int brief? Why is it inactive? Abob. Why is this inactive? What is causing it to be inactive? Oh, there's no interfaces in the area? What? There's no interfaces in the area. Is that because it's directly connected? No interfaces in the area. No interfaces in the area. So IP OSPF tells me there's no interfaces in the area. And there's 2, correct, there are 2 areas. External flood list length is 0. The backbone is inactive because there's no interfaces on the area. There's no... OSPF area 0 inactive. I'm a bit confused by that. The OSPF neighbor, hello and dead timers. We don't need... That's not a problem. Passive interface. Not sent to low packets, we don't need that. Because it times up the fine parts as well. A little bit confused as to what on earth is going on here. I don't have a VRF or anything. I could do. True interface. I do have a true interface which sends hello. So G0 0. G0 and it's up. Why is this? I don't understand why this is down. It makes no sense. G00, G00. I checked this. It's fine. Why would it not want to send over? I'm confused. This makes no sense to me. This is perfectly fine. There's nothing wrong with it, as far as I can tell. It's not something like this. It's really strange. That's annoying. That's really annoying, actually. Hmm. And there's any comments about that. Yeah, I mean, I don't see anything. I don't see anything that makes no sense here. I see that I have area 0. I've got OSPF 1 in the same process ID, and that shouldn't matter anyway. 2 is coming out. 4 is there in area 0. You know, it should be found. And if I go back to router 2, I don't see anything in the inter area, which is so strange. I should be seeing inter area routes here, and I don't. I see 5, you know, 5152, which is, you know, fine over here. It's both up. It's completely fine. Nothing wrong with it. Just show run. And no, area 1, which is where it should be. Area 1, area 1. So I don't understand what's going on here. It should be going through. Yeah, I mean, I don't see anything. I don't see anything that makes no sense here. I see that I have area 0. I've got OSPF 1 in the same process ID, and that shouldn't matter anyway. 2 is coming out. 4 is there in area 0. You know, it should be found. And if I go back to router 2, I don't see anything in the inter area. It's so strange. I should be seeing inter area routes here, and I don't. Interface, C5. Gigabit. You know, 51. Is there left 1? Which is. Yes, it's not enabled for the interface. You know, fine over here. It's both up. Completely fine. Nothing wrong with it. Just show run. And you know, area 1, which is where it should be. Area 1, area 1. So I don't understand what's going on here. It should be going through. Show IP OSPF interface. Show IP OSPF interface. There is no ISPF OSPF interface. Why? 192.168.50. 20 area 0. That looks correct to me. I don't understand what. Passive interface. No passive interface. Multicast filtering. I don't have any of that stuff. Subnet mask. It's not subnet mask. Subnet mask is fine. It's 3 and 0 0. IP address 12. No, it's fine. Hello, dead towers are fine. Authentication's fine. Area mismatch. Yeah, that could be a problem. I'm not seeing that though. It just says that the interface is dead. Like it's not up. Maybe if I do a conf t int g0/1 no shut? Nothing. Okay. Weird. That's really strange. I don't get why that's not working. Right, root to 0. It's part of the 2 network. It's a /30 anyway. It's not a 32. It's a /30. /30 on the interface just doesn't seem to be coming up. It's weird. But it is part of area 0, which it should be. It is not enabled. Oh, it doesn't make any sense. Why is it not? What interface is this? 01. It's 5.2. 01 is area 1. 5.2. So 5.2 is on this side. G0 is on that side. G0 is 252, yeah. So what if I just say 00? Is that dead? It is dead. Doesn't make any sense. Why is that dead? Zero. EN show IP OSPF interface. G00. That one's up, okay. So it does say that this one's up. So 00 on here is up. That's weird. So show IP root is fine. Show run is fine. It's number 2. G00 is up. It says it's a point to point. So it's a point to point. Point to point, okay. But 0 is give it 00. Okay, so 00 is up. Show run is point to point in a 252. It's a bug. It's a bug, 100%. So conf t int g00. I'm going to do a shot on that. I want to see if that has affected. Yeah, so it's nicely done. Okay. I'm going to no shot it on purpose. No shot. And that. There we go. That was the problem. It was a bug. It's a blasted bug. Now we're loading. Yeah, there we go. It's a damn bug. Alright. It's loaded. OSPF load fact. There we go. It's doing what it's supposed to do now. We're still not getting that one, so we need to do a... Before I move on, let's just double check we get neighbor detail. Hey, that's working now. Good. Check 01 is not enabled, so we need to conf t int g0/1 and then do a shot. Do a no shot. Okay, and that copy run start. Okay, and that's back up now. So 01's back up. Not designated router of this network, which is fine. No backup designated router on this network. Interesting. Okay, I need to check that. And that's probably because if I run the command here, we have 000. If I do 0. Oh, there we go. There we go. So we should. Oh, still not getting anything from that. Hmm. Interface. There we go. Give it a bit. And what's this? 0. That's working as well. Okay, it's working in 0, 1. Okay, fine. That's working. Interesting. It's not getting. There we go. That's what I wanted. Finally. Finally. Oh man, that took long. Right, I'm gonna take a little break and get back to you. Right, I'm gonna take a little break and I'm gonna come back. We're gonna tackle the NAT stuff. All right, see you in a bit. Ooh, that was a long lab. Ooh, right. All right. All right. Woo! That was a tough one. That was a tough one. Only because of that. Yeah, that was a tough one. I mean, that was just because of that that interface basically not coming up was what's causing the problem. Like, blimey. You know, that's why we weren't getting all the networks in. Unbelievable. Unbelievable. Yeah. So that was what's causing the problem there. Right. So we've done multi-error, we've done single error OSPF, we've done some debugging, which is good for the revision. And yeah, we've done the clear IP OSPF process as well. We looked at some of the debug commands, which is good. So that's good. Very useful for the exam. And then we did the priority as well, looked at DR. The only thing we haven't done is DR other. That's the only thing we haven't done. So we could do that right now as a bit for this lab. And we talked about that IP addressing scheme in area 1, which was just 5, right? So we had 5, which is 29 actually. So 5 to 29. And what we're going to do is we're just going to make it so that we do a show IP, show run. Just want to make sure I've got my interfaces down. And we've got 5.1. Right, okay, so 5.1's on this side. We'll do 5.2 on this side. Oh, the serial. Which serial version is this? 3. Okay, serial 3. INTS 0/30. IP header 192.168, and we're going to create this as 5.2. I'm going to create this as 5.2. And we're going to go 245.252.5.248. I'm going to call this area 1. Because I'm jumping ahead. Great, we're going to go exit that. Router OSPF 1. And we're going to use that. And I'm just going to do a network on this side. Network. Let's make this 0. 248 area 1. Good. And that should come back with an adjacency once I make that interface up. So let's go S0/30. And we're going to call this up. We're going to make a passive interface on the other side. Right? We've not done that yet. But that passive interface is going to come out on the other side of where the LAN is. Why? Because the passive interface, and I'm going to go through my revision notes on this, but my understanding is the passive interface makes sure that those LSAs don't come back into the LAN. Yeah? So passive interface, OSPF. So passive interface is using routing protocols to stop sending routing updates or hello packets, right? So we don't need routing updates or hello packets from inside of the LAN, yeah? We just need them on the outside, right? Where the OSPF interactions happen, because that will flood back into our network, causing it to slow down, which is never a good thing. So more memory, more CPU for no reason, yeah? So we're going to do that a bit later on, but for now we're going to do a no shot on this because we've already given it the IP address, which is fine, and that copy run start. Okay, and that's good to go. That's 2. We're going to go 3 on this side of the interface. So interface S3 S0/30 IP address 192.168. I'm going to call this, what did I call this? 5, yes, 5, okay, yes, 5.3, and hello? 5.3, nice, 52525.248, and overlaps with G00. Yeah, because it's part of the same subnet, but it's a different IP. So why are we getting that? Let's see. Exit, show IP and brief. Why are we getting that? Because that's a different IP. Oh, because I've already added. It's already on there. Okay, that's fine. So we need to go back to conft that one, no shut, because it's already on there. Incorrect IP assignment. Interesting. What do you mean? What do you mean it's incorrect IP assignment? It's fine. Hang on a second. What's going on? That should be fine. 248. And you're saying that's the incorrect IP assignment. Why is it the incorrect IP assignment? You just allowed me to put it in there and you're saying it's the incorrect IP assignment. I'm not sure why you said that and allowed it to happen. Alright, well, conf t int s0/30, no, boom, IP adder, overlaps. Hang on, but that's correct, isn't it? Let's see. Subnet mask 248. I'm sure it's correct. That's too much. Subnet mask. How many IPs? 8. Yeah, I was right. I was right. It means it's excusable. So yeah, I mean it overlaps in terms of the subnet. Yeah, sure, but it's still a usable IP. Why is that so picky in terms of weird? That's got to be a bug, surely, because that I should be able to assign that IP address. Why is that being weird? So you won't allow for the same. All right. Well, if that's the case, I could re-engineer this to be different. Kind of doesn't help though. I mean, if that's what you want to do, then all right, fine. So rather than that, because I was hoping that's what it was going to be, but it doesn't allow it, which is weird. Why does it not allow? I'm not sure why. Change to up. If I do a show, this is what's so weird. If I do a show run, it. Okay, fine. So 3, 0 doesn't allow for. Okay. Overlaps. Okay, fine. So if you won't do that, I could just use a 6 and create a completely different subnet. I'll call that 6.1, make it 2.5.2. There you go. Now it doesn't overlap. Do another shot. We need to do a network, router OSPF network. Router OSPF network. Router OSPF 1 network. Okay, we'll do a 192.168.6.0, and we'll do a 0.0.0.3. We'll do an area 1, right? Area 1, okay, fine. And copy run start. Copy run start. Alright, cool, that's fine. And then we'll go from here as well. So int s0/30. And then we're going to go and do our IP addressing again. We'll reconfigure this IP address. So we'll say 192.168.6.0. 2, we'll say 252 area, nope, we won't, we'll do that. And then we're going to go back and then do our router OSPF1, and then do the network, and then say 192.168.6.0.255.255.252 area 1, and yeah, there we go. Copy run start, show IP OSPF neighbor. Oh, there we go, fully loaded. Show IP root, and we've got 6, but none of the other ones, which is so strange. It's so weird. I don't get why the other ones aren't coming through. Show IP OSPF interface S0/30. What is up? Describes as point to point, but doesn't load. This is what's so strange. It doesn't load in all of the other routes that I should be seeing. I should be seeing a complete path in the OSPF inter-area network, which is really strange. So I see it wanting on the loopback to load, right? Which is completely fine, but but I'm not seeing the entire thing. Because I should be seeing some inter-area routes on both sides of the equation. Yeah, see, I'm missing a lot of routes. Okay, no, I've got 6 and 5. Okay. 6, 5, 1. 3 is missing, though. Is 3 being advertised out? And to whom? There should be a 3. Oh, 3 isn't being advertised. It should be advertised. Over area 0. Okay. Oh, right. Okay, I see the problem. So, router OSPF1 network. See, and we're supposed to be advertising this loop back out to all the networks. So that way, you know, you can use it for testing. So that way it's got a nice path into the test. That's the reason why we're doing that. So network, we've got 3.3.3.3, 252525.245, area 0. And I'm going to copy run start that, and we should be seeing in area 0 a route to 3. Oh. So it's lost 6. It's weird that it lost 6 as soon as 3 came up. So as soon as I put 3 up, it loses 6, but I get the admin distance and I get the metric of 2. But I lose 6. So inter-area OSPF is not its strong point here, is it? It's really strange. Show IP route. Show 6 is in the database. So you have a weird. Very weird. Alright, let me just move this up. You're supposed to have a bigger table, but you don't. So 168.6.1. I'm guessing it's not going to do it because you don't have a route to it, which is silly because he's supposed to. That's really weird. So by not advertising the loop back, that's really strange. So by not advertising the loop back, I get That can't be right, surely. This is why I don't like packet tracer with things like OSPF, because it doesn't really work. I'm going to do show run because I think there's a bug in this. So 2, 0. This is back again. But I didn't type that. That weird kind of bug is back. So router OSPF 1, which I don't want because that's completely wrong. And it's supposed to be 3 network, but it doesn't like 3. Just bloody weird. 3, 3, 3, 3, and then we'll just do not, which is what it should say. Do show run, and that's now fine. Weird. Very weird. So I'm not sure. Is that actually correct now? It is. Okay, weird. I'm going to end that. Copy run start. Copy run start. Alright, that's good. So that's fine. I should... Okay, that's... Oh, it's down. That's not good. That's not good. That's not good. You're supposed to have 3 in there. Let's see. Maybe it will come back. No. Man. You're directly connected, but you're not advertising out. So you're, well, not doing what you're supposed to be doing. INT G0/0 shots. No shot because you're not actually loading the database properly. And do the same thing on your side as well because you're not actually working properly, which is really annoying. Cop T, no, MTG00, shot, no shot, and move us on a bit. Alright, and now you've got your full loading, rather than caching. Show IP route. And that's what I'm supposed to be seeing. Yeah, I'm supposed to be a 3 here as well. There we go. That's better. I don't get that. That's an annoying bug. That's a seriously annoying bug. Because that's what I should see. And I see this is going to really annoy students. It's really going to annoy students because the problem here is, right? I know enough Cisco to know what my database should look like, right? Because I'm advertising them out. But a student which doesn't know that is going to be really confused by that. So if you're coming across OSPF errors, right, and you've done your point-to-point, you've done everything, right, and you're still scratching your head, do a shut and no shut on the interface in Packet Tracer. Never do it in production. Just do a shut, no shut, and it will come up with the actual database that it's supposed to have. I have no idea why, but that's what seems to happen. Even if I go through the timers, I fast forward, so that way it clears all the timers and resets the timers to clear the cache, it still gives me the same error. It's just unbelievable. It really is. Yeah. And going back to these metrics, right? So 2 on the metrics, right? Is 1 is gigabit Ethernet for OSPF cost. For any links which are being advertised. So for example, It should be like 65, 66 because the cost of serial connection is 64. So we look here, so you've got 66, which means that that's coming over the serial connection. And there should be, there's a route back. So we've got 1 and 1, which is 66. So from router 1, 1, 1, that's 2, 64 to router 4. And that's how that metric of 64 is calculated. Now 110, for those of you uninitiated, is the administrative distance. And that's why it's 110 there. If I was to put a stag route in here, it will be like 0, it will be like, sorry, 1. It'll be 1, but that's basically how the metric and the route is calculated. So when you see this, that's what it means. And it'll be coming up in the CCNA 3 as to what that actual metric means. So when you get this kind of question, be it inter-area or not, that metric is really, really important. For us to understand where it's coming from. I'm going to finish up here. I'm going to add these other routes in. Our network's coming along nicely. Now that we've, understood some of the bugs which are inherent. So I'm just going to finish this off, and then we're going to do some NAT and some ACLs. I think we're going to do NAT first, I think. So we've got 30. Okay, 30. What's name? We're going to call this ISP2. ISP2, and we're going to call this router 8. And we're going to use INT-S0/0 3 even. Ooh, thank you. 3.0. And we're going to use IP, we're going to use 7. 192.168.7.1. 255.252.252. Router, nope, not this. We got router. OSPF1. Must be at 1 up. Okay, fine. No problem. No shut. Thank you. And then we'll go back to router OSPF1 network 192 network. Thank you. 192.168.7.0. 0.0.0.3, and we'll call this area 1. And we'll come out of that. And we will copy run start that configuration. And there we go. So that's going to be up there. That's going to be a 2. Which one is this? 2. Okay, cool. En conf t int s0/20. Yeah. And we're going to do IP header 192.168.7.2. And we're going to do 0.0.0.3 area. Area 1. Area. Oh, okay, fine. Hang on a second. Bad mask. Yes, that's right. Because I'm going a little bit too far ahead. 245, 245, 252. Now that we can do all that stuff, we can go down to router OSPF. 1. Thank you. Network is going to be 192.168.7.0, 255.255.252, area 1, and we'll end that. Copy running start, copy run start, and we should see a show IP routes, and we're getting a lot of inter-area action, which is great. And we've got, should be 5 is directly connected. Okay, fine. 3 is into area, 4 is into area, 2 is into area. That looks good. Yep, fine. Yep. All right, cool. That looks good. Nice. Oh, hang on a second. What is this? 2. 2 was not up. Okay. Conf t int s0/20. No shut. And copy run start. All right. Show IP route is Now new one. Good. We got 7. 7, 2. 7 already connected. That makes sense. Good. Fine. Now we've got 8 on this one. Just 3, 1. So we'll just do 8. Conf T int S0/3 1. IP adder 192.168.8.1.255.252. Oh, let's say 1255. No problem. No shit. Exit out. Router. OSPF 1. Network is going to be 192.168.8.0. I'm going to do 0.0.0.3 area 1. Done. Okay, copy run start. And 8.1 is configured. Go down at 8.2. And let's check interface is 3.0. And we're going to do no down here, en conf t. Host name is going to be isp underscore 2. ISP 2 underscore router 8. And we're going to do a int s0/30. IP adder 192.168.8.0. Oh, sorry, 8.2. 25.25.25.252. And I have added 2 variables. There we go. No shut. There we go. And then we're going to go to conf t router OSPF 1. OSPF 1. And we're going to do a network, and we're going to do a 192.168.8.0. 25.25.25.252 area 1. Okay, and copy run start. Alright, and there we go. We've got loading in from the adjacency. And I'll do a show IP root. Oh, we've only got 2. That's bad. Should have more than that. Oh, there we go. Now it's come in. There we go. Inter-area OSPF down there. So if I go back to our other configuration, which is down here, now I do a show IP root, we should have a lot more in there now. So we've got 4 in there. So we've got 6 inter-area OSPF now. If I go here and I do the same, well, the same sort of thing. All right. How are we doing? 2.5 hours in. Okay. All right. How are people doing? There's nobody watching this now, so I guess it's fine. I'm going to go for a little break. My voice is very horsey, but we've done quite well. I wonder how you manage messages on OBS. Stats. We are still live, which is great. 3 gigs of data, nice. And apparently I can see the YouTube control panel and the chat. Okay. I've had 5 views on this. Oh, okay. Okay. Nice. Okay, I can dock these. Alright, okay. Any questions on that? I don't see anything in the chat, so I guess that's good. Yeah, 5 views. Yeah, so thank you to those 5 views. I guess that's very generous of you. Yeah. going to take a little break before we go back in. And yeah. Right, so what have we got left to do here? So we've got fiber optics going down into router 1 on OSPF 2901. We've got 2901 to router 6. HSRP to do on there. There's still quite a lot to do, to be honest. Okay, we'll have to do a little bit of thinking for things like NAT, for example. Include IP NAT inside and IP NAT outside, which is going to be a problem. I'll take my little break and then I'll get back on with it. So I think today we're going to do just NAT and OSPF, just get it all up and running. I'll focus on the other ones tomorrow. Ready for Monday. But it is hot today. It is really hot today. Oh, wow, it's hot. It is hot. 28 degrees today. Oof. Interesting day to do some Cisco. So I'm going to go and just come back in a second. Oh, good. I've got recordings. That's good. Very good. Okay, fine. Oof. right. All right. How are we doing? How are we doing? Nothing in the chat. Okay, fine, no problem. I'm assuming this is all going well for anybody who's watching this later on. Right. So we've done some OSPF on one side of the network. We've done side on the other side. Now we've got area 3 to do. I'm gonna spice things up a little bit, I think. Let's make. Let's do something interesting. We've got NAT to do still, haven't we? So. Ooh, NAT over HSRP. Damn. Okay. Let me think. So if I do, we'll just start with the fiber optic connection, right? So this is 0, 1. Okay, 0. So if I do, all you guys at home, so I'll do conft, right? int g 0/1. I think this is 0, right? I'm gonna give this an IP address. So IP address. Is there a way I can? Oh, okay. Right, IP address 192.168. No, actually I won't do that. This needs to be okay. 209.168. I don't know 0.1. 2525.252. 252. We're doing no shot. And I'm gonna take this IP and I'm gonna go here to 030, and I'm gonna basically do a conft int g030 0.3-0. I think. Ooh, okay. Okay, good, fine. What was I? Oh, right, yeah, okay. And this was on 030. I'm going to do a same thing here. I'll not use that, I'm going to use 2. Then do a no shut. And we're down. And we're down. Is this the right interface? 10 and 30. 30 has the interface as 2. Very good. 10 is down. What? Why are they both down? That's interesting. So G010 is down. Why? Show IP in brief. G010 is down. Are you kidding? You are having a laugh if you think that's down. Ain't no down. You're having a laugh if that's down, down. No shot. What do you mean down, down? It's not down, down. Seriously? Down, down? Weird. 030. It's not down. Come back up. Copy, run, start. How can that be down? Ain't no way. Ain't no way. Daft. I don't like doing this, but it kind of leaves me with no choice. Turn that back on because it's just being silly. Still down. Excuse me? Please show IP in brief. Down, no, it's not. It's not down, down. It's saying like I shut it down, and I'm like, no, I'm not. I've not shut it down. I've not shut this down. Why does it keep thinking that I've shut it down? It's not shut down. G010. No shut. What? Is this a... Hang on, so... Change to administratively down. Okay, good. So if I do a no shut, it changed the state to down. Why is the state down? What makes it so that the state is down? But it... Why... 10 is on. So... What? Why is it... at 30? Okay, 030. 030 is on? Is this a joke? I mean, that's got to be a joke, surely. Strange. So, it's refusing to come up? Is that a packet tracer problem? Multi-mode fiber not working. Oh. Speed, MMX, multi-mode. I did try multi-mode. That's weird. Yeah, OM4, yeah, but that's real. I'm looking at packet tracer, it's not. Uh, that's really strange. I'm not sure what's going on with that. What is going on with? Did I configure something wrong?
In the first example, and finally switch to add 3 computers to the topology and connect each one to a leaf switch. Align the topology. It shows 2 hops away. Turn the IP route command. From the topology, verify that router 0 has 2 interfaces.
Well, this is weird. Uh, how to connect to? Okay, to routers using. How do you connect them using fiber? I thought I did them correctly, but yeah, it doesn't show how to bring up the interfaces. It just shows connection. This is weird. It is up. It's not administrative, but it shows as administratively down. Do I need to save this or something? Try saving it. Mega Lab. That's weird. Okay, yes. Packet tracer? Let's see. Try opening up the lab. So it still thinks it's not right. Is that because of the power supply stuff? Or is that... What is causing that? Zoom in. Do we need some sort of power supply? 1 gigabit connectivity on all ISRs. Okay. I don't see anything. That suggests there's a problem. Weird. I am a bit lost by that. It should have come up. Maybe it needs single mode fiber? Is that what it is? Single mode fiber, maybe? I thought multi-mode would have worked, but maybe it needs single mode fiber. Single mode fiber works straight away. So it's a cabling issue. That's weird. I thought that was a multi-mode fiber. So hang on, LX is... You can have LXC. That doesn't look like single mode fiber to me. 1000 base LX-LH operates in gigabit Ethernet ports, and that's a single mode fiber. Wow. Okay. I guess it's single mode fiber. Let me just see. Can I ping the other side? EN conf t. We'll do the names later. Let's see. Show IP int brief. I have one on the other side. But yeah, we're fine. Good. All right, cool. So that works fine. So that's good. Okay, let's do that, shall we? And then we'll call that a day, I think, now. How are we doing for time? 3 hours and 2. All right. NAT Cisco configuration. So we've got IP NAT inside, IP NAT outside. I do remember that. And we have overload. Overload. We could do a DNAT pool, I guess. We could do a DNAT pool on router 1 rather than a static one. But we need an IP access list. Hmm. I need an IP access list, and I'm not quite familiar with them. I wonder if there's a tutorial that I can look at. Oh, here we go. And that's one of those ones that I'm not that good at. Which is why I'm learning, right? Which is why I'm here. This is why I'm learning, so. Peanut translations. Okay. Where do you put them at? Right, so we have access list 1 through 99 permits with the wildcard. Configure the IP access list. Configure the pool. What do I need to write for the access list though? Pool, so it's a named access list. Oh, it's a really bad tutorial that doesn't really say anything of which is definitive. Let's try Cisco's one. Gosh, that is one of those which just confuses me. IPNAT inside, IPNAT outside. Okay. So that's gonna be IPNAT outside. No, sorry, IPNAT outside is this section. IPNAT inside is this way. Okay. So I know where NAT's supposed to be. So I can do an IPNAT insides on G0. The IPNAT inside's here, which is G00. G00 is IPNAT inside. en conft IP, intg 00 IP nat inside, because I know that's supposed to be inside, and I suppose I could do int what is this, G010 int G010 IP nat outside. Okay, that's good. So that's, I guess that's good. I don't have a static pool. Map private IP addresses to the pool of public. Cause an access list to define which internal IP addresses are eligible. So, would that access list... Ah! It's a named access list, so I could just say access list. Oh, okay. It's gonna be... Well, it's gonna be everything on a 2 network, isn't it, really? Oh, dear. It's not a really good way of handling it. Hmm. Just trying to think. Should this be... How should this topology look like? Because it's correct, it's just not right. Um, hmm. I wonder if maybe... Because it's permitting 2 IP addresses over a subnet, which is not the way to do this. So, what I'm going to do is I'm actually not going to do this because it doesn't make any sense. Or does it? I mean, no, it doesn't. Because it's not an entire subnet. You'd have an entire subnet on this. So doing... Unless I permit another subnet, which is advertised from down here, which I actually have. So this is 8. Hang on a second. Show run, and this is, yeah, it's advertising 8 out. So I could do, what could I do here? I could do 9. Okay, alright, fine, I've got to do a slightly different thing here. En conft hostname, we'll call this sales office, and then we need to do an INT on this, so, oh, they're all back up to the switch, which is kind of annoying actually, because I can't do trunks down to an access. Oh, maybe I can. It's a layer 3. I've got to, oh, okay. It's a layer 3, but there's no, oh, there's no main interface. But I can trunk. Let me think about this. So how would I do this in real life? I'd have layer 3, I'd have my switch. Create interface VLANs on here. Do a trunk connection, access out. What if do I need to do that though? Because I might not need to do the trunk. Because it's a virtual interface. I wonder. What is this, 5? 1. G1. These are all G1, 4, 5, and 6. Could I do that? Could I do inter-VLAN sub-interfaces with... No, I need a .1Q, surely. Because the problem is, they would all go on... Oh man, that's a really good question. Oh no, oh! Oh, rooted and... Oh, right, yes. I'd have to... Does... Hang on a second. What is this? 1.6, right? So, if I go 1.6 with that... So conf... come on. Can't see the int G1.6. Can I do a switchport? I can do a switchport though. Switchport mode access? I can. So I can make that an access port without making it a rooted port. But then surely that means I can do a switchport access. I can. VLAN. Blah. So that changes the game a bit. So I can run that into the tag, but I wouldn't have a way of doing the sub int that I need. So 155 would be... Would that even work? I mean... 1.5... So... It would be a trunk connection... So I need to do DHCP... Oh, I need to think about how DHCP is going to be solved on here. So I could have a DHCP server IP helper address on the VLAN, do a trunk. I could do. Use an IP helper address. Could I not do it on the layer 3 switch though? Because that would be... Would I even need it? Because I could just... Yeah, I don't think I would need it, would I? Because I could just say... Yeah, like VLAN 5, VLAN 5, VLAN 5. And then I would just need to put the .1Q, but the .1Q is in sub-interface. I can't assign a VLAN onto a non-sub interface, can I? It'll be .1Q5 on a sub interface, but it needs to be reachable. There's no trunk. I wonder if that would work actually. Let's try. Roof that 5 doesn't exist. Okay. Put it on 5. What's this? Let's do a end show IP int brief, and we've got 3 to 6 active. Oh no. Yeah, 3 to 6 is active. Okay, cool. Conf t int range fa. Oh, sorry. G1 through G1 slash 3 through 6 swymo access VLAN swymo swyac swyac VLAN 5. So they're on VLAN 5. End that show VLAN. They're all on VLAN 5, which is great. Now I would need to create. Do I create an interface VLAN? On layer 3. I don't think that would be necessary. Don't need an interface VLAN. So interface VLAN's on there. So it would be, what would this be? It would be the trunk connection, but we don't have a trunk. It's on access. Still goes on at VLAN 5. Can I assign an interface? The interface is already assigned to the VLAN. But okay, let's do conf t IP DHCP pool. We'll call this cells. Network 192.168. We'll call this, I don't know, 10.0 255.25.25. Ooh, hello. 25250. Default router is 192.168 dot 10.1. Domain name. Oh, cisco.com. DNS server 1.1.1.1. Exit IP DHCP excluded IP address 192.168.10.1. Might need a relay. IP DHCP snooping is database. No. Okay. So that's on, but there's no option for a VLAN. But I wonder if I can go inside of the interface. Can I do something like .1Q? Will it let me? Or IP? IP DHCP snooping. Trust and limit, okay. So if I exit, can I do 1.3? Is there anything where I can... I can assign an IP address, but I can't do a .1Q without a sub interface. So it will give me the IP address key, but not the sub interface key. Let's see. Sub interfaces L3 switch. Encapsulation.1Q native. So enable interface gigabit. So you go back and do. Wait a minute, it's a sub interface. It doesn't exist. So if it doesn't exist, yeah, it just does the same thing. Configure the sub interface so that it has the valid .1Q encapsulation. But it doesn't need to be native, it just needs to be on VLAN 5. Could you, could you do that for a VLAN? Could you do like a VLAN, like VLAN 5, VLAN, it's like interface VLAN 5, interface VLAN 5, but I can't, could I? Oh. No, you can't. It doesn't register as a actual interface that way. Interesting. But you can, that's kind of annoying because you can create a I suppose I could create a trunk back to. Oh, was I supposed to? Oh, this. Oh, was that what it was supposed to be? Oh, right, okay. I see my problem. I need to erase this config. I made a mistake. Erase running config because. Erase the start config then. Complete. Alright, thank you. Because it's not quite right. Reload. No. Confirm. I made a mistake. Basically what I should have done is I should have placed the that config should be here, basically, in HSRP. And then what I need to do is I need to do a trunk, sub-interface this out, and make those two trunks available. but use HSRP on here. It's a bit of a pain in the backside, to be fair. Because I need to be on the same. Okay. It will kind of work, but it's like, yeah, a bit annoying. Conf-t IP DHCP pool. We'll call this VLAN 5, I guess. There's only one VLAN, so VLAN 5. Yeah, no, 192.168 10.0 2525.0. Sorry. Network, DNS routers, that 10.1 DNS. Oh, sorry. DNS servers 1.1.1.1. Domain name. Alright, sweet. So that's that. And we need a sub interface, don't we? So we need a fiber conf-t. And this fiber needs to be active. 1013. Let's see, intg0113. 113, is that it? 1013. Oh, okay. So G1013, no shot, and we need to do a sub interface of 5. Only routers can have sub interfaces in this version. Oh wow! Only even though it's a layer 3 switch. A layer 3 switch can't have, but it tells me directly I can. I can. Ah, really? Really? So are you telling me that? Oh, it's the same one, isn't it? Oh, wow. So does this? If I was to do a, no, go away. Right, enconf-t int g1/5.5. Only routers, yeah. Only routers. That's annoying. Okay. I would need to truncate VLANs. Alright, I need to think about this. Because DHCP is coming from the router now. Which ironically makes sense. Ironically. Yeah. So what I'll do is I'll do alright, hostname. Call this sales department. Call this sales department, and then what we'll do is we'll do a show and that show IP in VR. I've got 3 to 6. So I'll do a 3 to 6. I'll do a conf-t int range g1 1/3 through 6 swymo ac VLAN 5. Alright. end, copy, run, start. Alright. So those are all on VLAN 5. I need to do a trunk on 1, 2. I'm going to do a conf t int g0/1/2. Oh, or g1/2. 1/2. So I'm on trunk. Mode trunk. So I'm mode true. So that's a trunk. 1/1's got trunk. So I'm mode true. End. Shot. Okay, end. Copy and stop. Alright, good. So those two are up as a trunk. I need another trunk going into G105. Okay. INTG 105. No shot. SWIMO true. SWIMO true. And then another one at 1013. Okay. INTG 1013. No shot. SWIMO true. And I'll end that. Copy, run, start. Change that multi-mode into a single mode fiber. That was causing the problem last time. So what I'll do is I'll change this. I'll change that to a single mode fiber. From 13 down to 1. And there we go. Okay, that's up. And 020. Okay, we'll do 020. En conf t int 0 G020. No shot. Exit 020.5 IP addr 192.168.10.1 255.25250. Yeah, so encapsulation .1q 5. Do that. No shot. And end. Oh, that's going to be brilliant, isn't it? Because it still needs to be the same. Okay. End. Copy, run, start. And we need to do the same thing on the other side, which is kind of interesting. 010. This probably won't work. Conf t 0105 WQ5 overlaps as I suspected. Yeah, overlaps in the subnet. How are you supposed to do hot standby redundancy protocol and not screw up DHCP? Because it just overlaps. Unless you change it. I suppose that's... Yeah, I suppose you could do that. You could say 11. So change that to 11. No shut, which is kind of useless. So ng010, no shut. Still change the down. And there, copy runs. No, actually no. Copy IP DHCP pull VLAN 5. We'll do network 192.168.10.0.2525.25.0. Default router is 192.168.10.1, and we'll do DNS server 192.168.10.1, and I think that's it. We'll leave that at that. IP DHCP DHCP good addresses 192.168.10.1. I'm going to use 11.1 as well. Exit out that. Back to conf, and we're going to go IP DHCP VLAN 5 backup, and we'll go 11. Yeah. And copy runs dot. Okay. Yeah, that's good. Oh, did I make the pull for 11? Oh, I forgot to. Okay. There we go. Did I add one in for 10? I did. Okay, cool. That's that done. Alright, good. Now we need to delete these two things and create a single mode back to them. Multi-mode? Oh, single mode. Number 2. There we go. Alright, cool. So that's pretty good. Well, I'm not sure if that's going to get IP addresses. Because they're both on VLAN 5, so does that work as a DHCP configuration? Probably not. Oh, it's taking long. That's not good. Okay, failed. We'll have a look at that. Okay. Single mode fiber 214. Okay. Simulation mode, because I need to figure out what's going on. It's getting complicated now. Alright, play it. Interesting. What's this switch? Processes the frames, frame destination MAC. Broadcast, decapsulates PDU Ethernet frame. Uh,  'cause 105 up, 205 up. It's kind of annoying. Let me think. Um, so it doesn't see DHCP from there. It's trunked, right? So there should be, let me see. Show, oh, show interface is trunk. One is fine. Random span tree forward, not proven. Okay. Allowed in the trunk. 15113. 105. And we have 010. Show run 010. 010 is an IP address. 015 does it's 11. 02110. Should yeah, we have a DHCP server on both. Okay. What if I need .1Q encapsulation? T switch port. Maybe on the interface. So show IP and brief. Oh, damn it. 4? 5, okay. TG015? 10, okay, 105. INT, thank you. Let me think. So we got 105, and it's trunking. Switch port, trunk, encapsulation? No, just allowed. Native. So I don't have encapsulation .1Q. Packet trace. Decapsulates. This broadcast has the frame that matches the receiving port into the broadcast encapsulated. I don't think that's what's going on. Why does it drop the packet? Alright, I'm going to end the stream there, I think, because I'm a little tired now. And I don't know what's causing this. So yeah, there is that. But I do wonder what is causing that. It is very strange. Because it's trunked. Trunked, everything is fine. VLAN 5 is there. VLAN 5 is not part of the VTP configuration. Ah, that's what it is. Show VLAN. Okay. Right. Right. This is where VTP comes in. And I don't remember how to do it, so I'm going to need to just check VTP. VTP configuration. VLAN trunking protocol. Because I forgot how to do this. VTP server mode, advertisers, forwards. Oh, it's pretty easy. Okay. Conft VTP domain. Call this company. Yeah, that's the server domain. VTP mode server. Because no, we don't want that in the server. We want this as a transparent or a client mode. Yeah, we want this in client mode. VTP mode client. VTP mode client. VTP version 2. VTP version 2. VTP password. I'll call it Cisco 123. Cisco 123. Sweet. And copy run start. Alright. Now we need to do the same thing on this side. Conft VTP domain. And I'm going to just need to copy this domain because that's important, which is company. So VTP domain company. So VTP domain is company. VTP password is Cisco 123. VTP version is 2. VTP mode is server. Right. Do that on the other one now. En conf t VTP mode client. VTP domain is this. VTP password is Cisco 123, and VTP version is 2. Alright, and that's it. And copy run start. Copy run start. And copy run start. Alright, go back to real time. Show VTP status. Client number of existing VLANs is 6. Show VLAN. You have number 5 in there, which is active. Good. Show VTP status. Let's see. 1 to 2. Company. VTP pruning is disabled. VTP traps is disabled. Similar client, we have 6 VLANs, which is good. Show VLAN. And we've got 5 in there, which is good as well. So that means that's working. Right. Go back to simulation mode. See if we get an IP address now. And we do. There we go. 11. Let's go back down here. DHCP. Sweet. That's going through nicely as well. Alright, so that's DHCP sorted. We do have a little bit of a weird thing going on, which is basically that it gets two different IP addresses because of, well, we don't have etherchannel or anything configured here. That's for a later lab. We have a bigger problem, which is going to be NAT inside and outside, basically. Because the best place to do it is somewhere around here. See NAT lab before we end the stream. See, NAT Cisco lab. And that allows us to basically do network address translation from the inside to the outside. Nice little end there. You know, and we could do some nice things with that as well. Let's see. IP access list 10. Right, I'm going to take a break, come back and finish this, I think. Because I'm a little tired now. What time is it? 53. Alright, so we've got like another 7 minutes to the end of the stream. Configure and verify NAT for IPv4, and we've got port address translation, which is going to be like the overload stuff. That's what it's telling me on here. I'm just trying to think how I'm going to do this on my lab. R1 is up here. Configure now on R1. So what's R1 doing? So R1 has got access list permit. Run the pool on. Ah, okay. This is doing a DNAT pool. Okay. Inside source. So G001 is inside. Inside. So G00 is outside, right? Yeah. Okay. Okay. Default static root. Inside, outside. I'm tempted to do that on area 0. Well, it's not quite the right router. Maybe I could put a test server or something there. Hmm. I don't know. I'm gonna have to think about that. But anyway, I'm gonna end it a little bit early. But yeah, it's been quite fun doing that. Hope you learned something today. And then we're gonna go through another part and complete the lab. Really, a bit more NAT and a bit more IP access list stuff. So I just need to study that one up. Anyway, have a good night. I'll see you soon.